All right, problem 23. In the diagram below, triangle ABE is the image of triangle ACD after a dilation centered at the origin. The coordinates of the vertices of A, B, C, D, and E doesn't really matter. They already plotted all those things for us. Maybe it matters, I don't know. Let's take a look at the question. They want to know the ratio of lengths of B to E to C to D is what? Which one of these fractions? All right, by the way, that's a fancy, ratio is a fancy way to say fraction. All right, which one of those fractions represents BE to CD, right? BE divided by CD. So in this diagram, what I really need to know is the length, the number value of BE, and the length of CD. So I could substitute them in and then figure out, well, what does that simplify to? Which of these fractions will be my answer? So now it becomes, well, how do I figure out the length of EB? And if you look here, you have a right triangle. Therefore, you can use the Pythagorean theorem. So I need to know what my leg is, which is really easy. 1, 2, 3, because that's a horizontal distance. I can just count it. I need to know what my other leg is, and that's also real easy. 1, 2, 3, 4. Because that's a vertical distance. And this first triangle is really easy to solve because it's a 3, 4, 5 right triangle. So I know the value for EB is 5. That's that Pythagorean triple. You could actually substitute into the Pythagorean theorem to solve, but you should kind of remember those Pythagorean triples. Let's turn our attention to DC. That's a little bit harder. All right, the horizontal for that green segment is the 1, 2, 3, 4.5. 4.5. Okay. And then the vertical is 1, 2, 3, 4, 5, 6. 6. So in the Pythagorean theorem, a squared plus b squared equals c squared, and sure, I'll call that c. We're going to have 6 squared plus 4.5 squared, all right, the legs we found, and then we're going to solve for c. All right, so this is kind of calculator time. I know 6 squared is 36, but 4.5 squared, it's a little bit harder. I don't know that off the top of my head. let me clear that. So 4.5 squared is 20.25. Let's just add 36 to that, so I have that. 56.25. So 20.25 equals c squared. And when we combine them, we'll get 56.25 equals c squared. And since I'm solving for c, I got to get rid of that square by using the inverse operation. So c will really be equal to radical 56.25. So I'm going to do radical. I'm lazy and I'm going to type in my answer, 56.25. And it's 7.5. 7.5. So, boom. CD, right? This side here, from D to C, CD, that was 7.5. So clearly we're done, right? I just have to look for that in my answer choice and then I'll find it. So first one, nope. Second one, nope. Third one, nope. Hey, wait, none of them have 5 in the numerator. So they messed up, right? Obviously, Regis made a mistake. Unlikely. What you should do is type this fraction, this ratio, into your calculator, hit enter. You're going to, 0.6666. I know that. Isn't that 2/3? Well, you can do math, take your answer, and turn it into a fraction. Now look at that. It's 2/3. This thing really simplifies to 2/3. So now I can see answer choice 1 is my correct answer for that ratio problem.